All right, so we're going to finish up this lesson with a word problem. The shoulder height h in centimeters of a particular elephant is modeled by the function h of t is equal to 62.1 times the cube root of t plus 76, where t is the age in years of the elephant. So we're going to graph the functions using a table. Well, the best thing we can do here is go back to our calculator and plug in our function and get the data values. All right, great. We've entered in our equation. So what we're going to do now is we're going to go to our table. When we go to our table, we notice that we can get, shoulder height at 0 years is 76 centimeters. Great. Now, to find the other values, it's going to take a little bit of a while. So why don't we do this? We're going to go and we're going to set our table a little bit differently. So we're going to go to second, and we're going to go to window. And we're going to bring table setup. And instead of having our table count by ones, we're going to count our table by 20s, just as this goes from 0 to 20 to 40 to 60. So let's go ahead and have that count by 20s. So at delta TBL, we're just going to set in 20 here. And then we're going to go back to our table by going second graph. And that gives us a table counting by 20 years. So at 20 years, we're at approximately, we're just going to bring this graph over here, or the table over here, I should say. We're at approximately 244. We'll round it to 245 centimeters. At 40 years, we're going to be closer to 288 centimeters. And at year 60, we're going to be close to 319 centimeters. Okay? We can go ahead and then graph this. At 0, we get 76 years. Looks like we're counting by 65. So 76 is going to be somewhere right around here. In year 20, 245. It's going to be close to right about here. At year 40, we're going to be at 288. So I believe that's going to be right about here. And in year 60, we're going to be at 319, which is going to be almost right here. So we can kind of see that this graph is going to have this kind of flow to it. It's hard to tell where our point of symmetry is here. So I'm actually going to undo that until I get a better idea of where our point of symmetry is. Because as I'm looking at it, well, our point of symmetry should be at, should probably be at about 0.76. So maybe this is our point of symmetry, and we're looking at it like that. Okay. So much of the shape of the graph right now is not what I'm looking for. I'm more looking for the values and being able to talk about what's going on with this growth of an elephant. Okay. So now with that in mind, what is the y-intercept and what does it represent in the context of the problem? Well, our y-intercept is always going to be where x is 0. And that's 0.76. And if we think about what that represents, x in this problem, or t, I guess in this problem, is years of the elephant's age. Okay? Our y value, in this case, is going to be our height, or the height of the shoulder. So what we're saying is that at birth, the shoulder height of the elephant is 76 centimeters. That's what we're saying. So at birth, 0 years, the height of the shoulder is 76 centimeters. Okay. So now we're asking what is the approximate age of an elephant with a shoulder height of 280 centimeters. So let's go back to our table here. And we see we have 288 centimeters right here at year 40. So we could say the approximate age of an elephant with a shoulder height of 280 centimeters would be 40 years old. Okay? Because at 40, we have the point 40 to 88. So that's what that is going to come from. Now we need to calculate the average rate of change over the age interval from age 40 to 60. So basically, how much taller does that elephant get per year, or how much higher does the shoulder raise up between ages 40 and 60? To do this, I have an input of 40, and I have an input of 60. At year 40, if I go back to my table, at year 40, my height is 288 centimeters. At year 60, my height is 319 centimeters. So I have a point 40, 288, and I have 60, 319. To find our rate of change, we just remember this is x1, y1, x2, y2, and we know that our rate of change is the slope, so it's going to be y2 minus y1 over x2 minus x1. That is going to give us 319 minus 288 over 60 minus 40. That's going to be 31 over 20. Or approximately 1.55 over 1. The 1.55 represents our y values. Our y values are the height in centimeters, and our x values are the years. So the average rate of change is 1.55 centimeters of height per year. That would be our average rate of change from ages 40 to 60 of the height of the shoulder of the elephant. All right, that's today's lesson. If you have any questions, feel free to email me or contact me or message me through Canvas. Your homework assignment will be due on Tuesday evening, so you're going to get a lot of time to do 7.3. Have a great long weekend, and I will see you on Tuesday when I get back.